Imagine a world governed by the rhythm of seasons, where human muscle and animal power dictated the pace of progress. For millennia, societies remained largely agrarian, bound to the land. Innovation was incremental, often measured across generations, not decades. Production was localized, craftsmanship highly prized but limited in scale. Villages and small towns were the nuclei of life, and the vast majority of the population engaged in farming. This was the slow, steady heartbeat of humanity before the Iron Age of industry began to quicken its pulse, before dreams cast in metal reshaped civilization forever. Yet, beneath the seemingly placid surface, pressures were mounting. Growing populations demanded more goods, better tools, and faster transportation. The burgeoning empires and expanding trade routes of the 17th and 18th centuries highlighted the limitations of existing production methods. Wood, the primary fuel and building material, was becoming scarce in many regions, driving up costs and sparking an urgent search for alternatives. This confluence of demand and resource scarcity created fertile ground for revolutionary ideas, poised to transform human ingenuity into tangible, widespread progress across the globe. For centuries, iron production relied heavily on charcoal, derived from wood. As demand for iron increased for tools, weapons, and construction, so too did the consumption of timber. Britain, a nascent industrial power, faced a severe timber shortage by the early 18th century, threatening its vital iron industry. The forests were vanishing, and the price of charcoal soared, making iron expensive and limited. This environmental and economic crisis propelled innovators to look underground, not just for the ore itself, but for a new, abundant fuel source that could sustain a growing appetite for metal. The solution emerged from the unlikely combination of coal and a brewing process. In 1709, at Coalbrookdale, England, Abraham Darby I, a Quaker ironmaster, successfully smelted iron using coke, a purer form of coal, created by heating it in the absence of air, much like charcoal from wood. While others had experimented, Darby's innovation was the first practical and commercially viable method. His process removed impurities that made coal unsuitable for iron production, allowing for the use of Britain's vast coal reserves and paving the way for significantly cheaper and more abundant iron. Darby's coke smelting technique marked a profound turning point. For the first time, iron production was freed from the limitations of timber supply. The resulting cast iron was stronger and cheaper to produce in larger quantities, opening up entirely new possibilities. From agricultural implements to robust machine parts, and eventually, revolutionary structures, iron became the sinew of the emerging industrial age. This foundational shift in metallurgy made possible the complex machinery and infrastructure that would define the Industrial Revolution, literally forging the tools for its own advancement. As the demand for coal and iron grew, mining operations delved deeper into the earth. However, a persistent and dangerous adversary emerged: groundwater. Flooding was a constant threat, making deep mining incredibly difficult, hazardous, and expensive. Manual pumps and horse-driven systems simply couldn't cope with the volume of water encountered, limiting the accessibility of vast mineral reserves. This critical impediment highlighted an urgent need for a more powerful, efficient method of water removal, a challenge that would soon lead to another groundbreaking invention: transforming subterranean labor. The answer arrived in 1712 with Thomas Newcomen's atmospheric engine. Though massive, inefficient, and known as a fire engine, it was the first practical device to harness steam power for mechanical work. Operating by creating a vacuum through condensing steam, it drove a piston that powered pumps to remove water from mines. Newcomen's engine wasn't designed for rotary motion, but its ability to pump water continuously and at unprecedented volumes revolutionized mining. It unlocked deeper coal seams, fueling the very industry that fed its own appetite for fuel. For over 50 years, Newcomen's engine dominated, but its prodigious fuel consumption was a major drawback. Its inefficiency caught the attention of James Watt, an instrument maker at the University of Glasgow, who was tasked with repairing a model Newcomen engine in 1764. Watt identified the critical flaw: the cylinder was heated and cooled in every stroke. His stroke of genius was the separate condenser, patented in 1769. By keeping the cylinder hot and condensing steam in a separate, cool chamber, What dramatically increased the engine's efficiency and reduced fuel costs? What's further improvements, including a rotary motion mechanism and a sun and planet gear, transformed the steam engine from a specialized mine pump into a versatile power source. No longer confined to locations with abundant water or coal, these more compact and powerful engines could now drive machinery anywhere. This adaptability unleashed steam's potential across a multitude of industries. Factories could be built away from rivers, powering textile mills, flour mills, and eventually, locomotives and steamships. Watt's engine truly became the beating heart of the Industrial Revolution, enabling unprecedented scalability. Parallel to the innovations in iron and steam, the textile industry underwent its own radical transformation, primarily in cotton production. Demand for cloth was soaring, both domestically and for export. Traditional methods of spinning and weaving by hand, often in cottages, were slow and labor-intensive, creating a bottleneck. This burgeoning demand created an immense incentive for inventors to devise machines that could produce yarn and fabric faster and more cheaply, setting the stage for a dramatic shift from domestic handicraft to mechanized factory production, defining a new economic landscape. One of the earliest significant innovations in textiles came from John Kay in 1733 with his flying shuttle. This device dramatically increased the speed of weaving, allowing a single weaver to produce whiter cloth much faster than before. While a boon for weavers, it created an imbalance. Spinners couldn't keep up with the increased demand for yarn. This yarn famine spurred further invention, highlighting how a single breakthrough in one stage of production could create pressure for innovation in others, demonstrating the interconnected nature of industrial progress, driving a relentless cycle of improvement. The response to the yarn shortage came in 1764 with James Hargreaves' spinning jenny. This simple yet revolutionary machine allowed a single operator to spin multiple spools of yarn simultaneously, greatly increasing productivity. Early jennies spun 8 threads, but later models could handle over 100. It was small enough to be used in homes, but its capacity quickly outstripped traditional methods. The spinning jenny, though initially met with resistance from hand spinners fearing job losses, provided a crucial boost to yarn supply, helping to balance the production demands created by the flying shuttle. Richard Arkwright, a barber-turned-entrepreneur, further mechanized spinning with his water frame, patented in 1769. Unlike the spinning jenny, this machine was too large and complex for home use, requiring external power, initially horses, then water wheels. The water frame produced strong, durable cotton thread, far superior to that of the jenny, suitable for warps. Crucially, its power source necessitated locating production near rivers, leading to the construction of large mills and the concentration of workers in a single place. This heralded the true birth of the factory system, fundamentally changing labor and community structures. Arkwright's mills, such as Cromford Mill, were pioneering examples of the factory system. Workers, often entire families, moved from rural cottages to live and work around these industrial hubs. For the first time, labor was concentrated, specialized, and disciplined to the rhythm of machines, rather than the natural day. This shift introduced new concepts of management, timekeeping, and mass production. The factory system, born from the need to harness complex machinery like the water frame, would become the defining feature of industrial society, reshaping urban landscapes and the very nature of work. With spinning mechanized, weaving again became the bottleneck. Edmund Cartwright addressed this in 1785 with his power loom. Although early models were imperfect, loud, and prone to breaking, they represented a critical step towards fully automated weaving. When combined with steam power, the power loom completed the cycle of mechanization in textile production, enabling factories to produce vast quantities of cloth at unprecedented speeds. This invention sealed the fate of cottage industry weavers, as machines driven by inanimate power began to displace skilled human hands, fundamentally altering the economics of fabric. The mechanization of cotton processing in Britain had far-reaching global consequences. The demand for raw cotton skyrocketed, fueling the growth of plantation agriculture in the American South, where enslaved labor was exploited to meet the insatiable needs of British mills. Eli Whitney's cotton gin, invented in 1793, made processing raw cotton much faster, further intertwining industrial progress with human exploitation. The Cotton Kingdom thus emerged, a complex web of production, trade, and profound injustice that profoundly shaped economies and societies on both sides of the Atlantic, from the loom to the fields. While Darby revolutionized cast iron, wrought iron remained crucial for its malleability and strength. Henry Court's puddling process, patented in 1784, transformed iron production again. Pig iron was stirred in a reverberatory furnace, removing impurities and converting it into malleable wrought iron. Coupled with his rolling mill, which shaped the hot iron into bars with grooves, Court's innovations allowed for the mass production of high-quality wrought iron. This cheaper, stronger, and more workable iron was essential for machinery, railways, and bridges, providing the superior material required for the rapidly expanding industrial complex. The abundance of cheaper, high-quality iron led to audacious new architectural feats. The world's first cast-iron bridge, simply known as the Iron Bridge, was constructed over the River Severn at Coalbrookdale in 1779. It was a marvel of engineering, demonstrating iron's strength and versatility, a stark contrast to traditional stone and timber structures. This iconic landmark quickly became a symbol of the new industrial age, showcasing the power of innovation and inspiring engineers worldwide to envision a future built not just with wood and stone, but with the dreams forged in iron. Efficient transportation was crucial for moving vast quantities of raw materials like coal and iron ore, and finished goods, between burgeoning industrial centers. Roads were often poor and inadequate. The solution came in the form of an extensive network of canals, often dubbed liquid highways. Pioneered in Britain, canals offered a smoother, more efficient way to transport heavy bulk goods, dramatically reducing costs and speeding up delivery. The Bridgewater Canal, completed in 1761, was particularly influential, demonstrating the economic benefits and spurring a canal building craze that connected mines to markets. While canals revolutionized water transport, a truly transformative innovation was emerging on land, the railway. Early railways, using horse-drawn wagons on wooden or iron tracks, existed in mines. But it was the application of steam power that unleashed their full potential. Richard Trevithick built the first full-scale working railway steam locomotive in 1804. However, it was George Stephenson's rocket, built in 1829, that truly captivated the public and demonstrated the commercial viability of steam railways. Its success in the Rainhill trials heralded the dawn of a new age of fast, efficient land transport, shrinking distances. The rise of factories and the concentration of labor led to unprecedented urbanization. Small towns grew into bustling cities almost overnight, as people migrated from rural areas in search of work. Cities like Manchester, Birmingham, and Glasgow swelled in population, becoming the vibrant, yet often chaotic, epicenters of industry. This rapid growth, however, outpaced infrastructure development, leading to overcrowded housing, poor sanitation, and the spread of disease. These industrial metropolises, though symbols of progress, also became crucibles of social tension and public health crises, reflecting the complex duality of advancement. The factory system created a new kind of workforce. Agricultural laborers and skilled artisans were replaced by factory hands, performing repetitive tasks for long hours under strict supervision. Work moved from the flexible rhythms of the farm or workshop to the rigid, machine-paced schedule of the mill. Women and children were often employed due to their perceived docility and lower wages, becoming essential, yet vulnerable, components of the industrial machine. This profound restructuring of labor transformed social hierarchies and created new class divisions, defining the working class as a distinct entity. Among the darkest aspects of the Industrial Revolution was the pervasive use of child labor. Children as young as 5 or 6 were employed in factories and mines, often enduring horrific conditions. Their small size made them ideal for reaching into machinery or navigating cramped mine shafts. They worked long hours for meager wages, suffered frequent injuries, and had no access to education. While child labor was not new, the scale and intensity within the factory system were unprecedented, prompting eventual social reform movements and legislation, but not before countless young lives were irrevocably scarred. Not everyone embraced the march of progress. The Luddites, skilled textile artisans, rose in protest against the new machinery that threatened their livelihoods and traditional way of life. From 1811 to 1816, they famously smashed machines, particularly power looms and stocking frames, believing these innovations were destroying their crafts and reducing them to poverty. Though their rebellion was ultimately suppressed, the Luddite movement symbolized the widespread human cost of industrialization, the fear of technological unemployment, and the tension between progress and preservation of skilled labor, echoing debates still relevant today. Beyond economics, industrialization profoundly reshaped social structures. The traditional family unit, once a production unit in cottage industries, was fractured as men, women, and children left the home for factory work. New social classes emerged, a powerful industrial middle class, factory owners and entrepreneurs, and a growing, often exploited, industrial working class. The rigid social hierarchy of the past began to give way to a more fluid, yet often starkly unequal, society where wealth was increasingly determined by industrial capital rather than landed aristocracy. This created new avenues for mobility, but also new forms of poverty. The environmental consequences of the Industrial Revolution were immediate and severe. Factories belched smoke and soot into the air, creating dense smog that blighted industrial cities and caused widespread respiratory illnesses. Rivers became open sewers, polluted by industrial waste and urban runoff, rendering them toxic and unfit for life. Deforestation continued to supply timber for construction and charcoal before coke fully took over. The relentless pursuit of progress and profit, without regard for ecological balance, laid the groundwork for modern environmental challenges, leaving a legacy of ecological degradation alongside economic growth. By the mid-19th century, Britain had firmly established itself as the workshop of the world. Its pioneering role in industrialization, coupled with its vast colonial empire, gave it an unparalleled economic advantage. British factories produced goods for global markets, British capital fueled investment worldwide, and British ships dominated maritime trade. The nation's abundant coal and iron reserves, combined with a culture of innovation and a robust financial system, cemented its position as the world's first industrial superpower, setting a template for economic development that other nations would soon strive to emulate. Britain's industrial success quickly inspired other European nations. Belgium, with its rich coal and iron deposits, became the first continental country to industrialize, largely thanks to British technology and expertise, sometimes acquired through less than legal means. France, hindered by political instability and less abundant coal, followed a slower, more state-directed path. The German states, fragmented but eager to catch up, began their industrial ascent later, propelled by strong state support, heavy investment in education, and a focus on heavy industry. The Industrial Revolution was a tide that, once unleashed, could not be contained by borders. Across the Atlantic, the United States, initially reliant on British manufacturing, soon began its own industrial journey. Samuel Slater, dubbed the father of the American Industrial Revolution, memorized British mill designs and brought them to Pawtucket, Rhode Island, in 1789, establishing the first successful cotton mill. Later, the Lowell system in Massachusetts, an integrated textile production model employing young women, exemplified a distinct American approach. While initially slower, the vast natural resources, growing population, and pioneering spirit of the United States ensured it would eventually become an industrial giant. The groundbreaking inventions of the Industrial Revolution were fiercely guarded. Britain, seeking to maintain its technological supremacy, enacted strict laws prohibiting the export of machinery, plans, or skilled workers. However, such efforts were often thwarted by industrial espionage. Individuals like Samuel Slater, risking severe penalties, smuggled knowledge and designs out of Britain, eager to replicate the success elsewhere. This illicit transfer of technology played a crucial role in accelerating industrialization in other nations, proving that even the most innovative secrets eventually find their way across borders, spreading progress and competition. The true genius of the Industrial Revolution lay not in isolated inventions, but in their synergistic interaction. New methods of producing iron provided materials for steam engines. Steam engines pumped water from coal mines, providing fuel for iron furnaces and power for textile mills. Improved textiles created demand for better transport, leading to canals and railways, which in turn relied on iron and steam. This interconnected web of innovation created a self-reinforcing cycle of technological progress, accelerating at an exponential rate, demonstrating how fundamental changes in one sector could ripple through the entire economy. The speed of technological change during the Industrial Revolution was unprecedented in human history. Where centuries once separated major innovations, now decades, even years, brought forth new breakthroughs. This acceleration wasn't merely about invention, it was about the rapid adoption and commercialization of new technologies. The continuous drive for efficiency, productivity, and profit became a powerful engine, pushing the boundaries of what was possible and establishing a new paradigm of perpetual innovation that continues to define our modern world, constantly demanding adaptation and evolution. The Industrial Revolution, while undeniably a period of immense progress, presented a stark duality. On one hand, it unleashed incredible productive capacity, creating wealth, new goods, and laying the groundwork for modern conveniences and higher living standards. On the other, it brought about profound social disruption, environmental devastation, and widespread human suffering through harsh labor conditions and extreme poverty. This complex legacy forces us to confront the ethical dimensions of technological advancement, challenging us to balance innovation with responsibility, a dilemma that remains at the heart of societal development. While iron formed the backbone of the first industrial revolution, its limitations eventually became apparent. Cast iron was brittle, and wrought iron, while strong, was labor-intensive to produce. The stage was set for the next metallurgical leap, steel. Henry Bessemer's converter in the 1850s, followed by the open hearth process, made mass-produced, cheaper, and stronger steel possible. This innovation would power the second industrial revolution, enabling taller buildings, more robust machinery, and superior infrastructure, but it was the iron dreams of the early innovators that laid the essential foundation for steel's eventual dominance. The Industrial Revolution profoundly reshaped global power dynamics. Nations that industrialized early, like Britain, gained enormous economic and military advantages, expanding their empires and influence. Those that remained largely agrarian or dependent on raw material exports often fell prey to colonial exploitation or became economically subservient. The seeds of global inequality were sown, creating a world divided between industrial powers and resource-supplying peripheries. This era solidified a new international order, where industrial capacity became synonymous with national strength and global standing, a paradigm still observable today. The legacy of the Industrial Revolution is all around us. The principles of mass production, division of labor, and the factory system still form the bedrock of manufacturing. Our urbanized landscapes, our transportation networks, our reliance on fossil fuels, and even our globalized economy are direct descendants of this transformative era. It taught humanity how to harness vast energies, to organize labor on an unprecedented scale, and to constantly seek technological improvement. The world we inhabit, with all its complexities and contradictions, was irrevocably forged in the heat of those iron dreams, centuries ago. Yet, we must never forget the immense human cost. The stories of grinding poverty, hazardous working conditions, and social dislocation serve as a vital reminder that progress is rarely without consequence. The struggles for labor rights, better wages, and safer environments that followed the Industrial Revolution were a direct response to its excesses. Remembering these sacrifices underscores the importance of equitable development and the ongoing need to protect vulnerable populations as new waves of technological change continue to reshape our world, ensuring that progress serves all of humanity, not just a select few. The Industrial Revolution was more than a series of inventions, it was a fundamental shift in humanity's relationship with production, energy, and the environment. It unlocked previously unimaginable scales of output, powered by the mighty forces of coal and steam, transforming agrarian societies into industrial powerhouses. The roar of the machines, the smoke from the chimneys, and the relentless march of progress echoed across continents, forever altering the trajectory of human civilization. This engine of change, though crude in its infancy, set the world on an irreversible path towards interconnected modernity. From the humble workshops of inventors to the colossal factories that sprung up around them, the iron dreams of the Industrial Revolution continue to shape our reality. It was a period of both breathtaking ingenuity and profound human challenge, a testament to humanity's capacity for both creation and destruction. As we navigate the complexities of today's technological revolutions, understanding this foundational era offers invaluable insights into the forces that drive progress, the trade-offs involved, and the enduring quest to build a better world, one innovation, one industry, at a time. The establishment of factories marked a monumental departure from previous modes of production. Before, manufacturing was decentralized, often occurring in homes or small workshops. Factories centralized labor, machinery, and management under one roof, leading to unprecedented economies of scale. These early industrial complexes became magnets for migration, drawing people from the countryside and fundamentally altering the social fabric of communities. The very architecture of these vast, purpose-built structures symbolized the new era, replacing pastoral scenes with towering brick, iron, and glass, a new kind of landscape emerging. The insatiable demand for energy to fuel the burgeoning industries was met primarily by coal. Coal replaced wood as the dominant fuel, powering steam engines, blast furnaces, and textile mills across the industrializing world. This transition unlocked immense energy reserves, allowing for continuous and large-scale production, unconstrained by seasonal or geographical limitations of traditional power sources like water. However, the reliance on coal also introduced significant environmental challenges and became a central driver of the climate crisis we confront today, highlighting the long-term impacts of these early energy choices. The combination of specialized machinery, centralized factories, and an organized workforce ushered in the era of mass production. Before this, goods were largely handmade, bespoke, and expensive. Industrial processes allowed for the standardized, rapid, and cost-effective manufacture of goods in vast quantities. While this made products more accessible, it also fundamentally changed consumer culture, shifting from artisan craftsmanship to factory-made uniformity. The concept of interchangeable parts, famously championed by Eli Whitney, further streamlined production, making repairs easier and accelerating assembly, a principle still vital in modern industry. The Industrial Revolution didn't just transform production, it revolutionized global trade. Industrial powers sought raw materials from around the world and then exported their finished goods back to those same markets. Steamships and railways drastically reduced transit times and costs, making global commerce more efficient than ever before. This interconnected global economy facilitated the exchange of goods, capital, and ideas, but also perpetuated colonial exploitation and created dependencies. The world became a single, interdependent economic system, driven by the ceaseless churn of industrial production and the relentless pursuit of profit. This period was truly the era of the practical inventor. While scientific discovery laid some groundwork, many key innovations came from pragmatic, hands-on individuals solving immediate problems. From skilled mechanics like Newcomen and Watt to entrepreneurs like Arkwright, these weren't just theoretical breakthroughs but machines built to address real-world needs and create commercial opportunities. Their persistent experimentation, often amidst skepticism and financial hardship, drove the engine of change, proving that ingenuity, paired with a keen eye for application, could transform society more profoundly than any previous epoch. The Industrial Revolution fundamentally altered humanity's perception of time. In agrarian societies, time was often fluid, dictated by daylight, seasons, and natural rhythms. Factory work, however, demanded precision. The relentless, synchronized pace of machinery and the shift system introduced a rigid, measured concept of time. Clocks became ubiquitous, punctuality a virtue, and the working day became standardized. This new temporal discipline, driven by the demands of industrial production, infiltrated every aspect of life, organizing society around schedules and efficiency in a way that continues to define our modern existence. The financing of these massive industrial undertakings required unprecedented levels of capital. Entrepreneurs and investors poured money into new factories, mines, and transport networks, expecting significant returns. Banking systems and stock markets evolved to meet these demands, facilitating the accumulation and deployment of capital on a scale previously unknown. This rise of industrial capitalism created immense wealth for some, while others struggled to survive. The pursuit of profit became a dominant driving force, shaping not only economic policy but also social structures and individual lives, forever linking capital with industrial might. The Industrial Revolution was not a singular event but a continuous process of innovation and adaptation. Each breakthrough, from coke smelting to the power loom, created new challenges and opportunities, spurring further invention. This dynamic, iterative cycle of problem-solving and improvement became a hallmark of the industrial age. It demonstrated that progress was not static, but an ongoing evolution driven by human ingenuity, economic pressures, and the relentless pursuit of efficiency. This understanding of innovation as a continuous process, rather than isolated genius, remains central to technological advancement today.